right, here we're going to go, people. The question is, if 85.0 grams of potassium chlorate is heated, how many grams of oxygen will be produced? Now, I told you I was going to throw these at you. Okay? So, you're going to need to have your reaction prediction help sheet out, because we have to predict what is happening in this equation. Okay? We need to predict what is happening here. And we've left off with Maddie, so Sean, you are up right now. Okay? First of all, what type of a reaction do we have happening here? Okay? I would think again. Okay? What type of a reaction do we have going on here? He's trying to find his help sheet, so who can help? Who can help him? Naira, what type of reaction is this? It is a decomposition. You got your help sheet now, Sean? It is a decomposition, right? What? One. Number 3. Okay. Are you there yet? Did you find it? Decomp number 3. So, what does decomp number 3 tell you, Sean? A metallic chlorate heated gives you what? A metal chloride and oxygen. So let's go through, okay? What is potassium chloride? Excuse me, chlorate. Potassium chlorate is what? KClO3. Now, Sean, you just said that when it is heated, what is the first product formed? Potassium chloride, my metal chloride, and what else? Oxygen. Right? Excellent. Oxygen's a super 7. We have to have O2. Okay? So, Sean has number 1 covered. Now, Gabby, you go to number 2. What's number 2? Balance the equation. Is that equation balanced? No. What do we need to do? Where's our biggest problem to start with? Oxygen. Okay? I have an odd oxygen here, and I need to make that an even oxygen. So I put that 2 there to give me 6 oxygens. I'm going to put a 3 here to give me 6 oxygens. And then to finish balancing, I need to add a 2 there. So now do I have a balanced chemical equation, Gabby? Yes. What is step 3, Garrett? Determine the known and the unknown. Okay. What is the known, Garrett? 85 grams of potassium chlorate. That is my known. What is my unknown? How many, I'm going to circle my unknown. How many grams of oxygen? So we're at that step right there. All right, so we're at 3. What's number 4, Andrew? Determine the molar masses of both the known and the unknown. Okay? All right, Andrew, ready to roll. What is potassium chlorate? Excellent. 122.5495 grams per mole. What is oxygen? 31.9988 grams per mole. So, we have both of the molar masses. Excellent. Okay. Emily, the next step after the molar masses tells you to do what? Convert the mass of the known substance to moles. And that is a what? I told you to write down. What move is that? A flux capacitor. So when I sneak back to my flux capacitor, what am I doing? Where am I at? I'm up here at mass, and I'm going to go where? To moles. So what's my conversion from mass to moles? 1 mole over the molar mass, right? So I come back to my problem. 85.0 grams of KClO3. And I'm going to convert that to moles using flux capacitor. 1 mole of KClO3. And Andrew said was what? What was the molar mass? So, I need to double check. Do I have units that will cancel? Yes, I do. I have grams there. I have grams of potassium chlorate there. So I've now converted this into what? Moles of potassium chlorate. Ethan, I know you weren't here yesterday, but what's the next step? Moles of known to moles of unknown using the molar ratio. Well, mole of known was KClO3 in my balanced equation. Okay? What is the number associated with that? 2. 2 moles of KClO3. What was my unknown? What was my unknown? Oxygen. So I need mole of oxygen on top. And what is my number associated with that? 3. Do I have units canceling? Yes, I do. I have a mole KClO3, mole KClO3. So I have a cancellation there. Now, my final step, Joe, was to do what? Convert the moles of the unknown substance to the mass of the unknown substance. This is also a what type of a move? Flux capacitor. So if I head back to my flux capacitor, where am I at? Where am I at right now? Moles. And I want to go where? Mass. So what's my conversion? The molar mass over 1 mole, right? So as I come back, what was my molar mass of oxygen? Andrew? .9988. Okay, and I'm going to put my label up here. Grams of O2 over 1 mole O2. Do I get a cancellation? Moles of O2, moles of O2. So what is my final answer gonna be in? grams of oxygen. Is that what I was trying to find, Garrett, when you told me what my unknown was? Absolutely. So, now all you need to do is to plug the numbers into the calculator and get your answer. So go ahead and do that so we can make sure that we're plugging our numbers in right. How many significant figures do I have? 3. So I have my number as 33.3 grams of oxygen. What I would do here, and like I said, there's 2 ways that you can do it. Okay? There's 2 ways that you can do it. What I do is I multiply everything on the top. So, I take 85. Okay? Then, what I do is I divide by 22.5495 and then divide by 2. When you do that, you should get 33.3. You could do that, okay? You could multiply by the bottom, but you would have to divide and put those into parentheses. You can do that and it works out fine. You could multiply those together and divide by the total. Okay? Like I always say, there's more than one way to skin a cat. You can find different ways to do this. Alright? So, we're a little bit better than we were yesterday on this? Huh? What do you think, Kyle? A little bit better than yesterday? Okay, let's try one more. And I'm going to give you a second here to copy down the problem. All right, we're back. So, we're at step 1, Naira. What are you going to do? Tell me what we have here. What's the step, first of all? To write the skeleton equation, so we need to determine the reactants and the products. So what can you tell me here? Aluminum plus sulfur. Is sulfur a super 7? No. Okay. What type of a reaction do you have going on here? A combination reaction. So, what is my product going to be? Aluminum sulfide. What is my formula for aluminum sulfide? Al2S3. Excellent. It's nice work. Remington, you're up with the second step. What is the second step? Balance the equation. How am I going to balance this equation? A 3 in front of the S, 2 in front of the AL. Are we good? Okay. What is the next step, Ashley? To determine the known and the unknown quantities. What's our known quantity, Ashley? 35 grams of aluminum. What is our unknown quantity? Grams of the product. Now, what does that mean? What's the product? What's the product? Al2S3. So they didn't specifically tell us because the question didn't want to give away what the product was. They wanted Naira to figure it out when she did her combination. So, grams of the product, which is Al2S3. Next step is what, Maddie? All right, once again, I'm going to give you a second here, folks. All right, Maddie, what is the molar mass of the known? (26.981538). What is the molar mass of the unknown? Okay. Say that again. I didn't get 105. Anybody get something different? I got 150.158076. Okay. All right, you wrote it down wrong. There we go. See why we write everything down? Your whole problem would have been screwed up had you used that mass, right? That's why I don't just plug and chug in my calculator. So, now we have the molar masses. Sean, what's the next step? Convert mass of the known substance to moles. So, I'm going to take 35.0 grams of aluminum. Now, folks, I'm going to round my number, and the only reason I'm going to round my molar mass is so I have enough room to write it on the board. I would use, and I'm going to use, the entire big long number, but I'm just going to round it up here. Okay, so I'm going to round it to about 3 numbers after the decimal. So, 26.982 grams of aluminum, 1 mole of aluminum. Remember now, people, remember that this 1 mole of aluminum right here, I've seen many people want to go to the balanced equation and put a 2 right there. Do 2 moles of aluminum equal 26.982? Absolutely not. 2 moles of aluminum would be, 26.982 times 2. That is not what we want. We want 1 mole of aluminum there. Key point. That's where I see the most common error. Remember, the only time we go to the balanced chemical equation is to do what? The molar ratio. Excellent. Do I have a cancel? I better have a cancel. Did I get one? Yes, I did. My next step is to do what? Gabby? Convert the moles of the known to moles of the unknown using the molar ratio. What am I going to put on the bottom, Gabby? I couldn't hear you. What label do I want to cancel? Specifically, what of aluminum? Moles of aluminum. So I'm going to put that on the bottom. What is my number associated with moles of aluminum, Gabby? 2. What did I want to convert to? Okay. What did it actually say I wanted to go to? Grams of the product. What's my product? Aluminum sulfide. So, on the top, I'm going to put mole aluminum sulfide. And what is my number associated with that? 1. Do I get a cancellation on my units? Yes, I do. So, what have I converted this to right now? Let's stop right here. What will my label be? Moles of aluminum sulfide, right? Okay, my final step, Mercedes, is to do what? Okay, convert from moles of the unknown substance to what? Mass of the unknown substance. That is a flux capacitor move. Okay, so what am I going to put on the bottom? One mole of one mole. One mole of aluminum sulfide. What's going to go on the top? The molar mass, which was what, Maddie? 150.158. That's going to be good enough for me. Grams of Al2S3. Do I get a cancellation? Here's a mole of Al2S3. There's a mole. So my final label is going to be what, Kyle? Grams Al2S3. Go ahead and do the math. When I did my math, I came up with 97.4. What do you think? Are we better? Thumbs up. We better today than we were yesterday? You don't want to play the thumbs up game today, Kyle? All right. Okay. Now, final thing, final thought. Final thought. What is this actually telling me? It's telling me that if I start with 35 grams of aluminum and have plenty of sulfur there to react, how much aluminum sulfide should be formed? 97.4 grams. So if I have 35 grams of aluminum and plenty of sulfur to go with it, I should create 97.4 grams of aluminum sulfide. Okay?